let's take a look at what I call Unit 6 on probability. You'll notice that it's not a G out here, it's an S for statistics, and then it's conditional probability. Now, I will say this, that the original text in terms of what the Common Core put out, in the back of the book in the appendix, they gave what the traditional course of geometry might look like. And in that outline, they said to put in the probability. Now, those were just suggestions to states. Some have done that. Nevada, for instance, has. Others have. And others have not. For instance, New York chose to put that in another course. That's up to each state. Our mandate is to teach the core concepts, and each state got to figure out how to put that together. Some are integrated, like Utah, and so on. So some of you may not worry about this, but it's included in the materials because I made it for every state, and that way it was something that could go to any place at any time. So in Unit 6, we establish the ideas of probability. We get into sample spaces, very basic. We talk about independence. When is something independent? How do they impact each other? The idea of replacement, non-replacement. We get into conditional statements. Given that something has happened, what's the new probability? A couple things about these is that these mostly, the objectives speak to the development of the ideas, getting visual models, understanding them. It isn't so much about calculating. You'll see calculating comes later, and I'll tell you what I do. Conditional statements, two-way frequency tables, and then a little objective about where is this probability found in everyday life. Now watch what kind of happens. Number 6 here, we move to a B value, which means something's changed in what's going on. We're now calculating those conditional statements. So I got to be honest, I don't do all of this and then do all of this. This stuff moves up with the earlier stuff so that it makes sense to do the concept and then the calculations. The addition rule, of course, is the OR statement, the probability of A plus the probability of B minus their intersection, and then that equals, of course, the probability of A or B, called the addition rule. And again, that gets covered up here a little bit when we do basic things, and then it gets revisited again. The last two are honors topics. The multiplication rule, of course, is the idea of multiplying two events where one might impact the other. So again, that's just the probability of A times the probability of B, given that A has occurred, equals the probability of A and B. So again, that idea of conditionality, the multiplying through the more difficult concepts, knowing did it impact, how did it impact, what's the new conditional probability. And then finally using permutations and combinations to gather sample spaces, but as well to calculate probabilities.